the syntax.
Sir.
Tell me.
Sir, in case you're writing something, we can't see your screen.
You can't see the screen. Give me 1 second. Sorry. Not. Now, can you see the screen?
Yes, sir. Yes, sir.
Okay, so we are going to talk about the syntax and memory model of a C. So the idea is to highlight what are the differences between Python and C, correct? The syntactic differences and in particular the memory model and so on, correct? And we'll highlight the differences and also say something about the memory model. Okay, so how memory is allocated in C and so on, correct? So Python, if you consider Python versus C, what are called names in Python are called variables in C. What is the basic difference between names and variables? Names do not have types associated with them. And here variables have types associated with them. Correct? Similarly, you have values, and these are still values, and values have types, and here values also have types. Correct? But the values don't have a fixed type. You can have the type can be automatically changed. There are typecast things which automatic or explicit, whereby type of one object can be changed to another. So, but let's not talk too much about these. So what are types? So types are like int, char. So there's no char here. There is integer. There is string, and there is okay. So and then there is float. Float is also here, and so what is so what is crucial? One crucial thing about Python is this immutable versus, so values are immutable or mutable. There is no such distinction here. Correct? Moreover, one fundamental difference between not fundamental, but the eye-catching difference between the two things is two languages is that scope, etc. In Python is determined by scope a statement is determined by visual layout. What do I mean by that? Or indentation. Correct? If you indent a statement inside another statement, then it is in the scope of that statement. So for example, if you write while some condition, and then you write it here, this would be different from, so I don't even have to write this. I will just say while this thing, some such. On the other hand, you just write while something and this, then it won't even run, correct? It's invalid syntax. On the in C, scope is determined by explicit punctuation characters, and etc. So, so for example, if you want to define a function, so here, if you want to define a function like, let's say def function, and then args, or just an arg, let's say an arg, colon, and then you give the function definition, correct? Are you with me? Are people there?
Yes, sir.
Yes, sir.
Okay, good. On the other hand, here what we would write is something like red type. I will just say what red type is. F arg type, arg, and then there is this explicit open brace and close brace, which tells you the scope of this, correct? And these are types. So these are types. They could be int or char star or whatever. So let's not get into complicated types right now, but you have to specify the types of each of the, have to specify the types of each argument and also the return type. Correct? And notice that, and also, so this is the function thing. One thing which I missed out was you have to declare a variable before it's used, and which essentially means you have to declare the type of a variable before it's used, correct? So whenever you want to use an integer I, you say int I semicolon. So again, the semicolon, this is all punctuation marks. These are all punctuation marks, correct? Are you with me?
Yes, sir.
And any, okay, good. And any variables which are, for which you do not declare them or you do not give their type before they are used, will lead to an error. Similarly, the return type is not defined, is not declared, it will lead to an error. Of course, there are these exotic types like void, not very exotic, but still. So void is, there is no type, it stands for that. And there are variants like void star is a pointer which matches any pointer and so on, correct? So, so what does a function look like? A typical function would look like int function, and then you have the arguments char a, int b, and then brace open, and then you declare the variables that are local. So these are the arguments as usual, and these are the argument types. This is an argument type, this is an argument type. Types of arguments. Should have written this upstairs. Correct. And then you specify int I comma j, and comments are also different in C. You say something like this, and so I, j are variables. With type int, and this comma is just a delimiter. It's also an instance of punctuation, and is a separator, and this is a delimiter. It ends this statement, so to say, this semicolon. Correct? So you give this, and then you write some. So we will not be concerned too much about the actual statements, but by modern standards, the syntax is very exotic. You write, for example, I equal to 0. This is the initialization, while I is greater than or I is less than n, I plus plus. So this is the stopping condition. This is the initial condition, initialization. And this is executed before, after the body. And this is the body. Correct? So, so just to give you a flavor of things, correct? And now we come to something which is more important, which is the memory model. Correct? So we saw in file IO, what did we see? That memory is so basically read writes occur. So we saw that reads and writes do not occur in units of the data types that you have. They occur they occur in chunks of data called blocks. So IO occurs in blocks from the memory, from the disk. Correct? And disk is now a nebulous term because of all these flash drives and so on, but they are still referred to as disks. Correct? And so what are these blocks? So memory is divided, is organized in units of blocks, and it's not dependent on the data type that you're trying to write. Correct? So no, sorry. So in units of words. So blocks are made of many words. What am I saying? Sorry, words. Correct? And how big a word is? So usually so now we have the 64-bit architecture, which means that one word is equivalent to 8 bytes. Correct? Previously, there was this 32-bit thing and smaller this thing, which meant that one word was 4 bytes or even smaller. Correct? 1 byte is, of course, is equivalent to 8 bits. Okay. So you have this 64-bit memory. Blocks are something like so blocks are a larger unit. The blocks are 4 KB or some such value, correct, depending on the architecture. Correct. And so when you say something like int I, what does that mean? That means that you are associating certain number of words with int. Correct? So int is some X number of words. It could be one word, for example, one or more word. Correct? Similarly, long, there is a unit called long, and that is even longer. Correct? So it's 2 words or 3 or 4 words, something, some power of 2. Correct? So, and similarly, you can talk about floats. Correct? So, so now when you write int I, when is memory allocated for it? Remember, in Python, you have the Python is usually interpreted while a C program is compiled. Python is interpreted while C is compiled. Which means in C, there is more possibility of a static assignment of memory words to variables, correct? So you statically assign, let's say, global memory or static memory, which is not associated with a function call based on declarations. Some wars based on declarations. Correct? So now we want to know when is memory allocated, how is it allocated? Is it allocated statically, meaning before the program starts executing, or is it allocated when the program actually runs? So in C at least, so there are many types of memory, correct? Some static memory is allocated based on just the declarations. On the other hand, if you write a function like int let's say power a comma I, and you do it by recursive squaring. So and I say int I, int I a, int I, and it returns an int. And now you just like, let's write an inane this thing program which says, so let me correct it and write it properly. A to the I. C like syntax. In C++ and many variants of C, this is also a comment. We will use them alternatively. Correct. So how do you write this thing? Let's write a recursive program. So if I is equal to 1, return A, return. So here we are, let's say, assume I is greater than 0. And if I is less than 0, then, so I will not go into all kinds of cases. Return power A comma I minus 1 into A into power I minus 1, or let's, yeah, correct. So how will this and this, correct? So how does this because maybe this is not a good example. Let's change it slightly. So say we put in V, you don't return it one shot. What you do is V is equal to A, else V is equal to A into power A comma I minus 1, correct? And here let's so let me then correct, return V, and there is this thing here which I close here, correct? So is this okay? So now this integer V is internal to this power function. So when can we allocate space for it? Can we allocate space for it statically before the program starts executing? No, we cannot, because that would depend on what is the value of I, and this we won't know till runtime, correct? So we cannot exactly do it statically, but we can put it in the execution frame. So what do I mean by that? There is a execution frame where you store. So suppose you call power 5 comma 3, correct? So what will happen? First, this function will be called, and so at the bottom will be main. What is main? The function where the main program from which everything else is executed. So this is explicitly called main. So you will write, so what is the complete program? You will write int main, for simplicity, int main, and you will say, let's say, let's just say whatever it does, call power 5 comma 3, correct? Let's not put any other function. It doesn't do anything, it just computes it and exits, but let's just try this first, correct? So you would call main, and this would call power with the functions 5 comma 3, and then so this is the execution stack. this is accessible by the program. I mean, the program, while the program is running, this contains the various functions that are invoked. Correct? So main calls power 5,3. Then this calls power 5,2. Why is that? If you trace the program, you would come here and check whether I is equal to 1. So I is not 1, I is 3 here. And this, so I should in that space for, correct? Because when you call this power, this V is allocated an int worth of memory in the stack into V, correct? So these are the local, this is a local variable, correct? And this 5,3 are the A, I, which are arguments of this function, correct? So all these things are stored here. We would be set to, so we would enter this. V is still uninitialized. This would call power 5,2. Are you with me? And there would be a V for that.
Yes,
this would
sir.
call power 5,1. Okay, 5,1. And now when you enter 5,1, you will initialize the V in it into V. And then you would come here and check if I equal to 1. So now is I equal to 1? Yes, we are in 5,1, I is 1. So we would put V equal to A. So V would be set to 1, correct? And then, so, okay. And then this value is returned, correct? So wherever this, so control would return to the statement from which power 5,1 was called. Which is that statement? This statement, correct? So now here, this is gone. And instead, V is set to 5 into 5 into no, sorry, V is set to 5. We at 5,3. So 5 into 5, 25. Correct? And then this one is deleted. This, it is popped from the stack. And what is returned is this 25 value, which is again multiplied by 5 and get 125. Correct? And finally, this returns to the main, and that's it. So this is gone, and then, tell me.
No, sorry, what happens when it reaches the top? Like you said, it starts coming back.
Sorry, when it reaches, So what do you mean by it reaches the top? The point is,
power 5,1 after that.
So 5,1 number, it will execute this program sequentially. So it will check in V, it would create a place for V. I mean, that is, yeah. Then if I is equal to 1, it checks I is indeed 1. It would put V equal to A, it would put V equal to 5. Then it would return V. So it would reach this point. This else is not executed because it's not already if has been executed. So it would return V. And that is the end of the function, 5,1, that invocation. Correct? And that value is returned to power 5,2.
Yes.
Correct? And so on. Correct? So this is the execution stack. And so another, this is a very hodgepodge way of writing it, but a better way to write this would be main called power 5,2, and V would be set to V is unset in the beginning. Then this would call power 5,1. Then this would, sorry, main would call 5 comma 3, 5 comma 2, power 5 comma 1, 5 comma 1, and then this would return and set v is equal to 5. This would return v is equal to, sorry, b equal to 5. This would return, we said b equal to 25, we return and call b equal to 125. And then this would return to main, correct? Something, correct? But the execution is along this stack, correct? So this is one way to dynamically allocate memory, correct? But on the other hand, this might not suffice. Can you think of a use case in which this does not suffice? So suppose you are creating a linked list or a search tree or something, in which you create the tree or do some operation on it, and then you come back all the way back, correct? Then if you had stored this in your structure in this call stack, it would have been lost in this execution stack. If you had saved the structure, then it would have been lost once the executing functions are over, correct? So you need some other permanent storage for such memory, correct?
Sir, could you in this again? What you just said? This
Tell
example
me.
you, no, this example you gave. Could you explain?
I will explain. I will explain. Don't worry. Don't worry. But I'm just indicating where this example arises. Like you have seen this, you have created search trees, correct? Am I wrong or am I correct? In the assignments.
Yes, sir.
So in the search tree, when the program, so you create a search tree by using some function calls, and when the function calls exit, you don't want to lose your search tree. You want it to continue, correct?
Yeah.
So meaning you do a bunch of inserts, deletes, and after doing all of them, you still want the structure to persist. This persistent memory has to be somewhere not in the execution stack or not in the call stack, but somewhere is more permanent, correct? And so for that, what you need is another memory location, which is called the heap. And notice, so this is the heap. We usually show the stack as growing upwards and heap as growing downwards. Now, firstly, heap in this context is, let me highlight it, is not a min heap that we have talked about. A binomial heap, Fibonacci heap, it's none of those. It has nothing to do with the usual heap. This heap is just a pile, so to say. This is a synonym for a pile, but unfortunately it's the same word as the usual heap, but it has nothing to do with a min heap. Am I clear? Because every year people make the same mistake. They say that this is how the heap will work and how the values will bubble up and or whatever, correct? That is not what happens in this heap. This heap is just a name to store memory. Okay. So having said that, we will come to a heap in a minute. But first, let's see how storage takes place for an array. What is an array? An array you declare by saying int a50, for example. So array of, so this is an array of integers of 50 integers, correct? So it's a fixed length storage, and it is basically find I where it's located just from the declaration, correct? So if A gets a particular memory location, then A50 will get a memory location which is that location plus 50 times the number of words in an integer, correct? Or I times the number of words in an integer, or I minus 1 times the number of words in an integer, correct? Something like that, correct? So basically the location of AI is stored at position A0 plus I into number of words integer. Here, that's why I said number of words per integer. So exactly know how long an array is, and you can store it. So it's not a good practice, but you can store it in the stack also, correct? On the other hand, when we come to things like lists, then we do not know their length, do not know the length of a list in advance, and we do not know the position of an element in advance, correct? Because you might so a list is a list, it consists of a bunch of pointers, correct? So so how would you store it? So you store it in the heap. So how do you store it in the heap? When the list is created, suppose an empty list is, or a one element list is created. Let's say a one element list. Now it's extended by 1. So you store it at some position and put the pointer to that position, that address in this. So here you store the address of the first entry, and then from here you store the address of the next entry, and so on. Exactly like we are doing in the abstract data type, correct? Are you with me?
Yes.
So of course, if you initialize a list, so I should not have drawn it like this. If you initialize a list to so let me draw another heap. If you have initialized a list to say you explicitly list down the elements or the first 50 elements, then they would be stored maybe contiguously. There's no necessity, but they would be stored contiguously, and each one would point to the next one, and so on, correct? But thereafter, if you delete something here or splice something out, the contiguity will be lost, correct? Now, so this comes under this dynamic requirements are fulfilled using heap storage, correct? And so again, in another, this have a date pointer, this is your next pointer, and so on, correct? So memory is allocated on this as and when required in the heap. And the advantage of this is that once the calling procedures which created this memory have exited, even then this data structure persists, correct? So this data structure persists even after the creating functions have exited. Have exited or returned, correct? So basically, am I making sense?
Yes, sir.
Okay, good. So, so this is slightly different from, in some ways it is different from Python, because in Python, notice that everything, that all the values are on the heap. In Python memory model, you have names on one side and values on the other side, correct? So the names are stored on the stack, just the names, and their values are stored in the heap. So this corresponds to the stack and this corresponds to the heap. So there is no static storage at all. There is no storage inside the call stack. The call stack just contains names and the corresponding values are on the other side in the heap. Am I clear? So you
Sir,
store.
So the names on the stack, on the stack there's also a pointer to the corresponding place in the heap. Is that correct? Or,
Yes.
I mean, okay.
That's correct. That's correct. So,
Okay,
so, so the names are on the stack and there are values on the, of course, the values themselves might have embedded names in. But so like might have the later on things stored inside this, correct? And so on, correct? But basically the point is that values are always stored on the stack or on the heap. Sorry, what am I saying? Values are always stored on the heap while some of the names are on the stack. Correct? The variables are on the stack. Local variables and so on, correct? So, so let's say if you want to have a function that looks like insert. So suppose you want to insert a node L. So you have a node L, which consists of a list, and you want to insert an integer X into this list, correct? So we have written functions doing this in Python, and now how would it work in C or in Python, correct? So, so this function would work somewhat like this. You have the stack, So you show the stack as growing upwards. This is the stack. And you have the heap which is growing downwards. Correct? Now you first call the main function. And this would call, say, some function f, which would call some function g, and which would call the insert. Correct? So this calls insert. Now in the insert, so when you call insert, you would take the L and X, which are, so you would call insert with some L and X. These are variables, these are values which are accessible inside G, correct? So in G, you have access to these values which are on the stack, on the heap. So G points to something here, some two values here. One is a list L, and the other is X. You give, when you call insert, you give point. So let's call this L0 and X0 just to be this thing. So L and X get these values L0 and X0. So X points to this, L points to this, and now the insert function starts taking place. So what does L0 look like? L0 looks like a list. Sorry, what am I drawing? This is the next pointer, this is the next pointer, and so on, correct? So now you are pointing, this L0 points to the head of the list. And now you want to insert it. So you would have to do some replumbing like we saw. We would insert the, you would create something with X0 here. You would create a new item with X0 stored in that. And then you would, so whatever you do, so how would you do it? Suppose this contains y not. What it does is it would create a new thing with y not. Correct? So there are two things created called y naught. You would change this y naught to x naught because you're inserting, you want to insert x naught before that, and then you would change this pointer to the next one, next to the first one. So correct? And you would remove this and put a pointer instead to this. Correct? Something like this. So I presume you know how the insertion takes place, and now you can describe that in terms of these lists. So if I tell you to draw it, how would you draw them? You would show this, suppose y naught is contained here, and you have some z naught here, and this is pointed to by the, this is L naught, correct? And now you want to insert this X naught. So you create something, sorry. You want to create something which is an integer which is pointed to by X, this X naught, correct? So what would you do? You would create a new item which is like, so you would create first, create a node containing y naught, correct? So this is what it would look like. Then, and you can copy these two lists. So L0, Y0, Z0, and so on, correct? And now this contains Y0 again. Now in the second step, you would change this Y0 to X0. This is replumbing. So this is replumbing. And this would make this like this. Are you with me? And in the third step, you would take the pointer here and make it point to this one. So I should do it in another step, another diagram. In the C step, you would take this Y0, X0, Z0, and make this point to this. Correct? And in the D step, finally, you would take this X0, Z0, and this is pointing to this. And you would, no, sorry, this was pointing to this. So you would change this pointer to make it point to, and this was also pointing to this. You would make this point to this. So you're spliced in Y0 in between these two. So you inserted X0 in the beginning, correct? Are you with me?
Yes.
Sir?
Tell me.
When we were doing this in Python, there was a problem with, or rather we had to do something slightly different for inserting to the first slot because of the whole thing where we can't change what self points to. I guess that wouldn't be a problem here if I'm understanding.
Yes.
Because I guess we could directly change L0.
Yeah, that's true.
Okay, just wanted to.
No, but there is still a problem. But I will not. So let's not get into that problem in the context of C, correct?
Okay.
I mean, in C, you would. I would have to go into the details of pointers and references and so on. But what you raise is an issue, nevertheless. So let's ask a very simple question. Firstly, how are values? How are L, X, correct? This is a function call. Similarly, you can have a function call which says read X. Correct? You want to read a value into X. How will you execute that?
Sir?
Tell me.
So a question in the previous thing, was that in C or Python, whatever you sketched here? Is this algorithm, like this thing, does this happen in C or in Python, or it's not language specific?
No. So the issue that why we have to do replumbing was partly due to Python syntax, correct? But you could still do an insert like using replumbing. It will not break down in C. The question was, is it necessary to do it in C or not this way?
Okay.
Do you see my point? And that depends on so I think you can do it in C directly without using replumbing. But my point is, let's not get into the intricacies of pointers and references at this point. Correct? Whatever I have shown is correct in C as well as. Whether it's necessary to do it in C. Are you with me?
Oh, yes, sir.
But yeah,
Okay. Okay. So one question slightly tangentially related was, how do you read a value into a variable? So what you want to do is to execute read x, and then x should contain, suppose x is an integer. Correct? You don't want to return the value, you want to read the value into x. How will you do that? So, I mean, if you say something like in some mixed syntax, if you say def read x, x is equal to input, int input, correct? Then once this function is execution is over, you would not have x contain the value of that was read from the terminal. Do you see why?
It would be local to this function, so we
because
need
it's
to
local
somehow.
function and the value is value is the variable is passed as a value. Only the value of the variable is passed. It's not passed by reference or by. So it's not passed by reference. Meaning, if you change something, the value of x, it will not be reflected outside. That is why I said this is like self. Self is passed by value. That is why these two things are related. Do you see my point?
so what is like self? Like read x? Like what
Huh?
is like? You said something is like self. What is like self? Like what exactly is like self?
Self is the pointer to the current object. When you have an abstract data type, you define some object, correct?
Yes.
Self points to that object, correct? The current instance of that object. And in Python, there is only call by value. So if you change the value of self inside this, inside a function, it's not reflected outside. That was the root cause of why we had to do this replumbing, correct?
Yes.
On the other hand, in C, what you can do is to, you can write a function that looks like int read int ampersand x. Some this thing which where you say where if you change the value of x, will happen. So reflected out. At least in C++, this is what happens. In C, you can do another thing, which is to int star x, correct? So you pass a pointer to the object you want to read. So you would call read and x, and so let's call this a pointer for clarity. and then you would change, you would do star p is equal to int input, something like this, correct? So this would alter, tell me, you pass the address of the variable. When you call this, you pass the address of x to this. Tell me.
No, your voice broke up when you explained in read. Could you explain in read in an
Okay. Okay. So what I'm saying is, in C, you would maybe in the calling part write something like read ampersand x, int x, read and x, and then read is defined thus. Correct? So what you're doing is you're creating an integer x, passing the address of that x to the function read. In that function, you're dereferencing pointer, putting it there. So you're reading this value in the address which is in the memory location which is pointed to by p. Correct? So it's a bit complicated, but you can do it this way. Correct? Now, some more things that I wanted to say before I finish today's lecture, which is that we have touched upon this earlier also. We touched upon garbage collection. I'm reading in the deallocate. So automatic garbage collection. This is automatically deallocated periodically. On the other hand, in C, you have to explicitly deallocate memory that you have allocated on the stack. Correct? So, for example, when you delete a node, you have to write a function that actually removes all the memory that is associated with that node. Unless you do that, it will remain in the heap, whether or not it is accessible from the program or not. Correct? Are you with me? So,
yes, sir.
Okay, good. So, uh, uh, this is left undeallocated or undeleted, then this is a memory leak. We have talked about this in the course, correct? But in any case, this causes a memory leak in plus type languages. This, on the other hand, this or close down the entire system. So it's not very efficient. but it's safer, so to say. Correct? And yeah, so another thing is that black box is very from program is of course user, and if you do it explicitly, we could have a user doesn't mean all the it is unsafe. So is unsafe. You can maybe create more garbage by deleting things, not deleting things properly. So you delete only part of the memory, and then that garbage can never be removed ever because it's not accessible from the program any longer, and so on. Correct? So that, and one last thing is in C++, you specific allocators. New and V. New is correct. In the abstract data types, there is underscore init, correct? Function is similar to this. Free is something when for deallocation you have to explicitly define. In there is allocator, it's not specific. You have to explicitly type, convert the type, the typecast look. Memory, typecast the memory to. So basically, calculate how much memory by the number of locations you want, and just ask for that much memory. If the kernel has that much memory, it will return it to you. Correct? So
Sir?
Tell me.
Sir, could you repeat the last part again? Your voice was breaking for me.
Okay. So in C, you do not have type-specific allocators or tellers. You just generate function malloc or calloc, whatever. So malloc, in malloc, you just or malloc, you just say the number of bytes you want. Correct? And then you typecast it to the appropriate type. Correct? So you just specify how much memory you want without specifying the type of the memory you want. Correct?
Okay. Okay, sir.
Correct? And then you can store whatever you want over it, essentially. There's a lot of freedom, but there is also unsafe because you might store something which is not meant to be stored there. I mean, and there are by not meant to be stored, I meant suppose you do your calculations wrong and you overshoot the memory you have asked for, then you might write to places where you're not supposed to write, and this might cause unexplained effects in the program, and this happens a lot in C. Correct? So safety of programs is very difficult to ensure because there's much more freedom. In Python, there is less freedom, but it's much more safe. And ensuring this safety takes the efficiency of the correct. So basically, that is are there any questions? No. Okay, good. So next Tuesday there is no class. There is a quiz on Thursday, and we will see after that how much, or before that how much we can cover. Correct?
Sir, what is the reference for the topics that you covered today?
So that's a good question. I mean, there is one reference that I can tell you. You can search on the net for call stack, for heaps, not min heaps, but memory allocation, and the keywords that I've listed. You can search for them on Wikipedia or something, some reliable source, and do that. There's no one book which I can recommend.
Okay, sir.
Okay.
So,
Okay, more questions. Tell me.
do we have C in N7? Like,
you don't have C, but the basic memory model and what I covered in today's lecture, that is in the course.
answer, will we have to code, or is it like pseudocode?
So there might be small portion just to check that you know Python, but most of it would be in pseudocode. But definitely there'll be a question on actual code. One question at least.
Yes,
Correct. But I think you have spent enough time on Python to be able to write that simple code. There will be no intricacies there. I mean, more questions?
Sir, I had two questions.
Tell me.
About the way that the stack is there in C for like the call stack. Conceptually, I get how that worked, but how, like, when we say that there is memory associated with the functions on the stack, how exactly does that is that working, sir?
So so when you look at the function declaration, correct? Hello?
Yes, sir. Yes, sir.
So when you look at the function declaration, whatever are the local variables associated with it, and whatever are the variables that are passed in the as arguments,
Yes,
that total memory you can estimate, correct? That total memory you can find out.
Yes, sir.
Correct? So that much memory is allocated on the call stack for these variables.
Okay, and by on the call stack, do we mean that there's a pointer from the call stack to whatever location it is, or?
No, on the call stack. In C, it is on the, I mean, I don't know whether it's actually on the call stack or not, but that call stack returns, that memory is deallocated. So for all practical purposes, it is only on the call stack. That memory is forgotten, so to say. It's not deallocated.
Okay.
When you go beyond that, it is no longer there. You don't have access to that memory. Correct?
Okay. Okay, sir. Okay. I think I got it, sir. Thank you. Sir, my other question, I think this was asked last time also, but I didn't quite catch the answer. For the quiz on Thursday, what are the portions?
So everything. Everything till today.
Sir, for the quiz or for the I was asking for the quiz, sir.
For the quiz, yes. For the quiz, yes.
Okay. Okay, sir.
So I will
Okay.
upload this just now. I'm going to upload this just now. If there is any glitch in that, tell me. Before tonight, I will upload it by tonight. Correct?
Okay, sir. Okay. Thank you, sir.
Thanks.
Thank you, sir.
Okay, thanks. Bye.